Nice to meet everybody here. My name is Ahmed Khalifa. I work as a solutions architect for a company called Architech in Toronto. I have some stickers and pencils for you. Sorry I'm late. Most of you live here, I'm assuming. If you ever get a job in Toronto, say no, because the traffic is horrible. I spent the last 2.5 hours in the 401, which was not nice. So, today I will talk to you about something that is quite simple and yet quite advanced. So I am sorry if I disappoint you if my talk is not super technical. What we have tonight is about our experience in developing our monitoring system. I'm trying to share with people our experience in trying to have a solid monitoring system. And I think we learned a lot from where we are now from where we started. So I will quickly introduce Architech and I will discuss with you the 4 things that people like to monitor. And I'm going to urge you to get to know your constituents and be a good monitoring system principle. And then we will discuss the value of the whole paradigm we're advocating in Architect is to embed monitoring into your software development lifecycle. Just like everything else that used to be done after we finish development, you know, performance tuning, all these things that we used to do at the end of the projects, like 2 weeks before we go into production. Oh, we haven't done QA. So now we try to make these things like first-class citizens. And I'm going to urge everybody to start small, like use agile principles, and we're going to have some Q&A. So in Architect, we are 13 years old. We've been in the business for some time. Started by 2 consultants winning a big project in Rogers, and then expanded from there. We have more than 100 people, some of them in Krakow. We have design, strategy, and engineering practices. Engineering practices around 30 engineers or so. I come from the engineering practice. And we have built more than 300 projects. We are partners with some of the very names that you heard about here, like Microsoft Azure and Red Hat. So I can probably answer some of the discussions that was happening here earlier about Azure. And I do a lot of cloud-native architecture, so I'm quite interested in questions like, why do you go to GCP? Or why do you go to Azure? There is always good reasons for doing these things. So, somehow the formatting is not working well today, but that's okay. So, in a cloud-native application development, which is what we do at Architect most of the time, we get stuff on the left. This is the development cool stuff, right? We're doing, you know, we're deciding what are we going to do. Are we going to go PaaS or serverless or using Lambda or something like that? Or are we going to just use infrastructure as a service and put our Spring Boot and use Spring Cloud ourselves on it? We are definitely using containers everywhere. I don't know why containers is really popular with developers. Like, you guys never get configuration, you never like configuration. Somebody put a whale icon on it and somehow it's cool suddenly, so I'm good anyways, it's great. On the right side, this is sort of, you know, the boring stuff that architects do. We worry about elasticity, resilience, composability, monitoring and metering sometimes if you're doing SaaS. I guess Shopify will be involved in metering. Security, stuff like that. So, what are the things that you should monitor? Who here has a monitoring system up and who up? All right, and who here is planning a monitoring system? Curious about building a monitoring system. All right, so the first thing, what are you going to monitor? When I was young, these are the Fantastic Four. Then Google came with their site reliability engineering thingy, and they said here, and we turned to agree with them. In the end, that seems to be the right answer. Four things that you want to monitor. You want to monitor latency. If you're monitoring latency, please be careful not to mix errors with real responses because errors will be very fast. If you have no connection to your database, that request is going to come back much faster than anything else. And also some other errors will be timeout errors, so they can go up to 30 seconds. And these two types of errors will skew your latency numbers. So you want to get rid of these numbers. You want to make sure that you don't get errors. And I'll describe the tail thing in the next slide, which is a very tricky part. I figured it deserved a slide myself, because we've seen it as well. Traffic, not just latency, you want to measure traffic, how much you're getting, how many requests. You got to be careful in selecting your traffic. Errors, 500 explicit, implicit, and the rate of errors. And finally, saturation. Saturation, we use other things sometimes than help to do. So if we want to monitor CPU load, if we want to monitor memory, if we want to monitor, sometimes we like to monitor our containers, our swarm cluster. We use something like log or something like that for it. So this slide is dedicated to the median. I don't know who studied. Anybody studied statistics here? All right, cool. There's cool 4 people here, and the rest of you should all aspire to be as cool as these 4 people. And I have the honor of studying statistics as a postgraduate in Egypt, like 25 years ago. And I went and I studied as an undergraduate again in Canada. Like, I just went in an undergraduate course to study it again. It is such a cool topic. Everybody should understand statistics. So, one of the biggest problems with statistics is words like median. And then we say the median response rate is, or the average response rate, and we advertise this to clients and customers, and we look forward to it, and it's written in our SLAs, and it's horrible. One of the biggest problems with medians is that they come from something called normal distribution, or they come from multiple distributions, but we all assume that life is a normal distribution. Normal distribution is the height. We look at the height of everybody in the room. So just a quick intro to normal distribution. We assume everything is a normal distribution. Here is a sad fact about life. Not everything is a normal distribution, and we are wrong. Companies like my previous employers would assume employee performance is a normal distribution. So they say only top employees are good, like 2% of employees are excellent, 2% are horrible, and the rest are in the middle. That's like a normal distribution. That's not true. All economists assume that markets act according to normal distribution models. And Nassim Taleb in his book, Black Swan, proved that this is wrong. If the market was a normal distribution, we'd have a recession every 54 years. The reality is we have recessions every 6 to 8 years. So normal distributions are wrong, and we should not use them here, and I'll tell you why. Now we're going to see why this is a bad idea. So this is looking at the response times, median response times, let's say every, I don't know, 5 minutes or something. And the median is 419 milliseconds. So at each point of this chart, if you guys are familiar with Elastic, and when you look at your, when you do the visualization, and you're aggregating the numbers, and you're saying, you know, every minute, every 30 seconds, or whatever, and then you're doing median, and you see something like this. So let's say you want to be under 800 milliseconds. It's acceptable under 800 milliseconds. You look at this and you say, yay, that's awesome, maybe we are performing very well. Maybe we need to pump it up a little bit, but it looks acceptable, right? Here's a problem. If I take any one of these, this is one that this average here, the median for all these transactions, this is now a single transaction. The median for this is 491 milliseconds, which is quite below my 800 milliseconds acceptable range, right? But as you can see, the median does not really represent how happy my customers are. Because my customers will be unhappy above 800. I break my license agreement with them above 800. And all these guys above the red line are unhappy. And if I look just as the median, if I just take that nice visualization of medians, I'll be wrong. And now Is disconnecting. And it is back. So now I'm sad. You can see the face became sad, and I have a watermark on it too. So this is what I would like to do, and this is something you can do. Instead of doing medians, get a histogram and aggregate at a certain point of time, and aggregate buckets of response times. So say, this is how many requests under 200 milliseconds, how many requests 400 milliseconds range, how many requests in the 600, and you can do that. If you go to your visualization, you can just go to a histogram, and you can choose how you can follow the period of your histogram. And then you can look at this histogram. That gives you a much better idea, because then you can say, well, from 800 and above, I'm going to count. I have 15, 10, 4. This is what, 29? 29 out of 99, that's 30%. 30% of my requests are above the license agreement. We failed, right? And this is the type of, this is what Google means when they say, watch the tail. This is called the tail. This is actually a very fat tail in statistics. This is the outrange. So consider your numbers carefully. Just because you have a pretty chart, really that chart does not help a lot. The second part, which is very interesting, and I think this is probably the biggest lesson we learned. When we talk about monitoring, there is an ecosystem. Monitoring doesn't exist in the space, in the world, without anything connected to it. So we have an Elasticsearch, and we have Datadog, and we have New Relic, and we have Prometheus, and we have all these amazing, wonderful technologies that allow us to take a look at our systems. But what are we looking at? Do we know what are we looking at? And is there a reason why we pick what we're looking at? And we found that the answer to this question is not really easy. There is an assumption, and every developer thinks we want to look at everything, and this is absolutely not true. I can tell you that right now. So a bit of an understanding of how your organization works is very important. I'm going to show you now a fictional organization. It's inspired by my long career in banking systems and big retail in Canada. Your organization, I'm assuming here you guys are way cooler than us in Toronto, so your organization is probably going to be much more fun, but just bear with me. So you will have your software developers, and these really are very good guys. They're very smart, they write good code. What you want from them is to generate events that you can monitor. And anything is acceptable these days. You can write something to a log, you can write something to a queue. Actually, we have one app where we were writing to a log, and speaking of Kafka, we were using the Log4j Kafka writer. So the developers didn't even know they were writing to Kafka. They were using Log4j as if everything was fine, as if nothing was happening, and they were logging things to Kafka, and Kafka was piping that stuff to Elasticsearch in the end. So they can generate events, smoke signals, just tell me what the hell is going on with your app, and I'll take care of it after that. Maybe I should just join the chat. I seem to be moving too much. Then you got the platform engineers, and these are a little bit of a rare breed. These guys really like to test and control and build, and they do the monitoring, and they understand how all the systems connect to each other. Who here is considered himself a platform engineer? Yeah, I got 3, 4 hands. These guys, they never say no. Like developers, if you don't know everything about the language or the work you're doing, you don't consider yourself an expert, you never work with it, you say, no, I don't know it very well. Platform engineers just throw us at something we've never heard before in the morning. By the afternoon, no problems. We're the experts. We're always 5 minutes from being like a scam, but we're very comfortable in that world. And we can connect, right, yeah, you agree with me. So, and we connect these things very well. So we can connect everything together, because otherwise the world would stop. Yeah, they are very rare. When we hire them, I generally pick guys who are much bigger than me, big beards, and they generally make you uncomfortable alone in the elevator. Like, they look really really scary. Then you got the support engineers, which is something that we struggled with. And mostly what we have built was a lot of the pain we had was support. Because support has not been traditionally somebody who's an engineer. If you look at the support engineer role, it was not really an engineering task. They were just getting tickets, figuring out which component broke. That just didn't help. But these guys are very important. So what the support engineers do, they are the users of your dashboards. So if you want to design a dashboard, the support engineer will be your customer. I don't think you can build a dashboard or a system without asking the support engineer first what you want to do. They also receive a lot of notifications. When something goes wrong and a pager comes up that something went wrong with a customer, not with a system, the support engineers are the people who will find out. Who stays on the phone with the customer is a support engineer. Who collects information about the problem after the problem has happened is a support engineer. Who will take that information and tries to find the accurate log file in 250 Docker Swarm instance log files will be the support engineer. So you want to make their life easy, right? They are also constituents. Then you got your ops guys. These are, of course, the heroes that we all aspire to and admire. These are the guys that know everything in the system, knows how the system runs, and they also have their own dashboards. They are different. They're watching mostly CPU utilization, they're watching memory, they're watching Java heap, they're watching Docker instances. They are also receiving pages, not about client tickets, but receiving pages about system performance. So if some systems heat up, if the database goes down, if something goes kaboom, things go bump at night, they get a pager and they respond. And you want to alert them. One quick word about alerts. It's a very known fact, but somehow everybody ignores it. Alerts are very, very expensive. So don't throw them easy at people, because every time an alert happens, a human response is usually required, unless you have an automated response to it. So be careful with your alerts. Too many alerts will destroy your system as worse than no alerts at all, actually. So now that you understand how you build the system, you cannot build a monitoring system without talking to all these characters in the fictional in your organization. In your organization, you have a different, I'm sure each one of us have a slightly different approach to doing that. You want to talk to people, find out what they want. So for example, my support engineer wanted all the log files in one place, wanted the log files names tagged with the container name or with the host name that generated the log. And what I have done for them is I worked with our platform engineer, where every time there was an exception, Logstash from the metadata of the exception will generate a URL for that file, and we have an Nginx server serving these files over HTTP after they have been aggregated. So you see the exception, you get a link, you click on the link, bam, here's the file with the time span that had that exception. So if you, I mean, maybe I'm traumatized, but I worked for banks before where they had a 16-node WebSphere cluster and a problem would happen, and we would go look in 16 different servers in historic files looking for that exception. And sometimes exception roll over, and sometimes we kill the old logs, and it was just a disaster. So now we got all that stuff, it's under control. We move to the last, sort of before last piece, which is, okay, so we do all this good stuff. When do we do it? Do we do it at the end of our project, in the middle of our project, or when? And this is something I am pushing for. I can't say, in all honesty, we do it right now, but I will tell you that I am pushing for it as much as I want to, as much as I can. So what we want to do is embed this in at least every 2 weeks in our sprint planning, in our grooming session. I want the support engineer and the operations engineer to be in the room with the application team, looking at their own scenarios. What do they want? So assume we have a login screen. You would say, okay, I have a login screen, and what do? You go to OAuth and all that or something. Generally speaking, these are the scenarios you have. User can log in, we go to authorization, excellent, or invalid login. The user cannot log in. You can either retry or say, okay, let me send you a password reminder. Maybe you want to add one for like registration or something, right? But that's what we developers think of. We support engineers, we operations guys will add something to that. We will come and say, no, I think there's other scenarios. It's a timeout scenario. So generally speaking, the development team, your customers, your users, your product owner would never think of a case where you are not actually able to communicate with your LDAP or with your OAuth. That just doesn't happen, right? But if your support engineer and your operations engineer are in the room, they're going to say, that happens. So when they say that happens, if that is part of your grooming session, you will develop stories you develop stories with your platform engineers about, okay, how am I going to monitor that login? What kind of data I need from that login story? What kind of dashboard I'm feeding from that login story? And you work on that. And you also give your development team a hint, hey, this is a good place to put like a circuit breaker. This is a good place to put somewhere because to give errors to the user, a timeout, 542, like server error or whatever, 500 serious error, or is just not cool anymore, right? So I think there is great value in doing that. The other side of it, like in our small experiment that we ran, the other side of it is that this kept our support engineers in the engineering process. That made them feel like they are engineers after all, and they are participating in the project, and their requests are here. And that gave us really a better monitoring system. The downside to that, I have to admit with you right now, is that this grew up faster than we expected. Suddenly, every story had a dashboard, every story had an alert, every story had a problem. And then we had to consolidate that later on. But that's a different problem for another day. Now I'm going to go very quickly, and this is just, these two slides are to tell you one thing and one thing only. Do not ever fall into our mistake, and everybody else's mistake, I guess, of designing and building your monitoring system and preparing it, rolling it to the world, and stay in the room for 6 months building something, thinking that you're going to roll it at once. This just never ends happily. And funny enough, we built Agile engineering to get rid of that model. But when we build our monitoring system, we somehow forget Agile engineering. So build it small and deploy it and get feedback and iterate, and don't be afraid to roll out dashboards that people are going to throw away and make changes to it, right? So start with your lowest common denominators, like alerts and dashboards is the basics that you need. Maybe later on you'll have a custom portal where you mix your historics and your data log and your Kibana and other things together, and maybe you'll have your Kibana dashboards customized with parameters. Yeah, you want to be cool, no problems. You can build automated responses, you can rebuild indices, you can restart databases, you can restart clusters after they fail, based on alerts. That could happen as well, but don't try to do that in your first iteration. Just give yourself a breathing room. You can go to this whole self-healing theme of services, and in the end, you can do predictive analytics. The reason I thought that was just, everybody knew that, right? But then every time I go to a meetup and we talk about Elasticsearch, and I meet all these people who have never implemented an Elasticsearch cluster in production, and what they ask about is predictive analytics and the AI that Elastic is bringing up, which is fantastic. It's a great feature, and it's very exciting. But we can't start from the top of the pyramid. I mean, I'm sorry, I don't mean to discourage anybody from using it. It's great, you want to use it. But start with serving your team and serving your clients. And the same applies to what you do inside, even alerts and dashboards. The first thing you do is a heartbeat. Like use file beat, just get a heartbeat on your signal. Then you can look at your error logs, and then you can look at your traffic, and then you can start looking at your saturation using something to monitor infrastructure. Then you can go, okay, now let's go to the latency and do the funky, do the funky statistic stuff we talked about earlier. Then you can go to alerts. Just everything in steps. And finally, this is, your cycle. You deploy something, you put it out, your ops and support, who are your customers? Your customers is the ops and support, as we agreed. The ops and support guys are going to come back to you and say, we need to adjust this, we need to adjust that, you're alerting us too much, you're not alerting us fast enough, this screen is confusing. Take their feedback, just go create some development requirement, rebuild it, and just take feedback from them again. So in summary, you want to monitor as little, but just as much as needed. Not too little, not too much. You want to be smart about your metrics, make sure you're monitoring the right things. You want to get to know your constituents. Please get to know your support and your operations. The people who are using these dashboards are very important. And sometimes they are the members of the dashboards, but in many cases they are not. Get the development and the support and engineer in your development lifecycle. Start early. That will pay handsomely in the end, and start small. Iterate. So that's all. This is my contact information, and if there's any questions.
So where is cloud involved in here? Cloud, where is it involved?
Okay, so where is cloud involved? Cloud, for me, is a removal of the, what do you call it? Non-differentiating effort. So I would consider Logs.io a great cloud solution in the context of Elasticsearch, maybe. Elasticsearch is a great product, but I found, as Shopify has found, that maintaining an Elastic cluster is an effort. Maintaining indices is an effort. Building a lot of these dashboards and monitoring things could be an effort. So if there is a service cloud solution, I would use it. On the other hand, you'd want to avoid vendor lock-in. So we are not using Azure OMS, for example, which is a very comprehensive monitoring solution, just because it's Azure. And it forces everything to go to Azure. So if I have a client that wants to run in AWS or in GCP, they will not be very happy with the solution deployed between two cloud platforms, and they're paying for two cloud platforms, right? So we use cloud for that. To be honest, we use containers a lot, so we are just about to move to container services, and container services have been new. Yes?
Is that because they put a cool whale on? Is that because they put a cool whale on?
Cool, cool whale, yeah. So the cool whale, I don't know. I have been for a long time trying to convince developers to learn about their infrastructure and about their ops and networks and how things connect to each other. And they would like almost throw it back in my face, right? With disgust, like, you're disgusting. I don't want to deal with this stuff. And then suddenly Docker comes and they're writing Docker Compose YAML files and they're writing Docker files and they're very happy. But that's exactly what I wanted you to do 10 years ago. Anyways. I mean, I don't know, I don't know. It's probably a lesson in psychology. I should try to say things in a cooler way, cooler things. So yeah, so cloud plays a role in that area. Also, cloud plays a role very important in producing a fast, elastic solution and experimenting sometimes. So if you are experimenting, you can easily, we have scripts in our team for the development of stuff. For Elasticsearch, for example, we have scripts that he builds a Docker-ready Microsoft Azure instance and puts a fully configured Nginx and Elasticsearch on Docker instances using Docker Compose with SSLs, with our own self-signed SSL certificates, everything secured with basic auth in maybe 40 minutes. And we built that because we assumed every project. So maybe I need to digress here for a second. So we work with many projects. We're a consulting firm. At any moment, we have 3 or 4 projects running, and they range from like I don't know, Roto-Rooter in the U.S., very funny people, to coal miners in Canada, to shipping ports, to startups. So we have 4 or 5 projects running using different technologies generally, mostly Java, Spring, Node.js, React, and Angular. So each one of these projects would need to develop their own dashboards, they need to develop their own monitoring system. So I need to stand up for every project this monitoring environment very quickly. So we use Docker. But when we go to production, we generally use Ansible because just Docker makes it more expensive, and I really don't need to bring elk like this and bring it up like that again. That's just not important. Any other questions?
You mentioned at the beginning that you have cloud expertise. So my question is, are all the cloud providers going to integrate everything inside their platform? Or, as you mentioned before, if you have a customer that wants a piece of Azure, a piece of Google, and a piece of Amazon, yeah, are these cloud providers open to the other platforms, or each one tries to contain everything in their own?
So there's an interruption here. Yeah.
Thoughts about having developers take support calls to make them basically
all right. So your question is going to take a lot longer to answer. So we can take that on with beer. I need beer with that.
Okay.
And I know a few things about cloud. Yeah, that's a very good one. So I don't know. Did you read the Google SRE book?
I haven't read it.
Okay. So I'll give you a funny thing about Google SRE, which is really cool. And I don't know, like, I'll give you my thought that I dare not probably speak loudly among my developers. So yeah. So the paradigm is this. The paradigm is 50. So the paradigm is that every project has a budget of errors, and it's a 50% target for the support engineers, which are the Google SREs. So if you're a support engineer, you're spending 50% of your time in getting calls and answering calls and finding problems, and 50% of your time writing code to automatically answer these problems and to monitor the system better. If your effort in any project to do calls and manual stuff exceeds 50%, that extra goes back to the team that built the code. Not only that, but also that team is sort of not allowed to add any new features until they fix whatever it is that is making them so broken. So it's like a cool old engine back pressure, valve system. The more you build heat, the more it's going to build back pressure against you, and then it kind of fixes itself in the end. But then even there's exceptions to that, because sometimes systems are broken, and if you spend more time trying to fix a broken system, you ignore the root cause. So sometimes you need to target the root cause, so they allow for flexibility on that. But I don't know, like our support, we hired a support manager when we started our support system, and because I was the architect and I'm handling the operations and stuff, and I was like, okay, I'm working closely with him. Then he had a family problem, and he had to travel overseas, and he disappeared for 3 weeks. Then he sent an email saying he can't come back, and we couldn't hire someone else since then. So I became an acting support manager, and my phone is basically our support phone. So it really depends. Like, I really don't know. It's very tough. My thought is that after a certain limit, we need to get them involved. Maybe we can have like a weekly meeting. I mean, I'm looking at these ideas myself. Maybe you have a weekly meeting where the support team would go through the most interesting tickets with the development team, just to make the development team understand where the problems are. But I think if they worked earlier together, things would be better.
I think getting the developers exposed like this is probably not the right idea, right? Because that means your QA layer has failed. So your QA layer should get involved first to understand why these things are actually making impact to the customer in the first place. And then, if you need feed, then you go back and figure out why the developer not developing things. Is there a problem of health, or is it a potential problem of they're not conveying expectation of what needs to be in the right place?
QA to me is one of the most vague terms in history. Like, sometimes I don't know what is the Q and how they are Aing it. Right? Like, I think, I mean, I tell people I left Royal Bank of Canada. I was probably thrown out of the Royal Bank of Canada by the QA team. Or maybe they had a party after I left. I had a big problem with the QA team because here's the deal. Okay, what is Q? What define Q to me? I mean, where is the quality that you are wanting?
I'll give you a perspective.
Yeah.
The development team is not a one-single team. It's like really little men pretending to be one big man, right? Because they all work on the little things. They all the vision they have is very common. Their expertise of what they're working on.
No offense, anybody.
Whereas the QA team was supposed to bring a broader vision to what the product is supposed to be. How it all works together, how it figures together, how
So the product owner is the person that brings the vision, right? Now I have a challenge. Well, yeah, so I have a challenge. I mean, the product owner is a startup or like a small company, or sometimes the product owner doesn't really have all the pieces. And so, I mean, I'm with you. I share the same pain when we have the same problems, and it's very hard to overcome. Just by having a QA team that is like dedicated to QA, that never solved the problem to anybody, right? That never solved the problem. And I'm with you as well. Having the development team by themselves do it did not solve the problem either. You almost need one like advocate for quality in the team, and they will be pressured by management and schedules because they tell them we have no time for that. Yes.
If you get them to carry a pager. If you get them to carry the pager, get them to carry the pager for their software.
Yeah.
Quality will improve for sure.
There is that, but like I think developers we sometimes don't give them the right credit. I think developers, if they challenged hard enough with the QA problems early in the game, they take great pride in what they do. We were building a very big, complex, Spark-consuming, Spark on Hadoop file consumption processing system, and I took some time to myself, and I was leading the team, and I said, guys, here's what I'm going to do to you. I am going to corrupt these files coming to you, and I want to make sure that your code does not break. And we started I did something like Chaos Monkeyish on it, like I took the files on a script, and then I started also sending the files in the wrong time order. And guess what? Because we had a third-party provider coming through our FTP server, sometimes the files arrived in the wrong order. But it was nasty when we were doing it, but when it was done and we were doing our testing, we came out like champs. We were heroes. So.
Right, I know I shouldn't comment on this, but I will. Ever so slightly.
Yes.
So from a QA perspective, it's like theory of where you should involve. It depends on how much money you want to dedicate to quality assurance.
Give him the microphone.
Do you want the mic?
The better part of 15 years doing aerospace and defense contracts. So when you put a line of code in an aircraft,
you need to know determinism. So X happens, Y always happens. No question mark, no determinant. But in order to do that, it makes software development, software testing exceptionally expensive, which is why we pay millions of billions of dollars for a plane that may or may not ever see the ground, like the F-35. However, that level of methodology has been defined to say, thou shalt do this. But your QA is involved, not from code development to theory. They're involved at the same time that somebody's writing down the specifications on the paper and say, this is how it's testable. But it gets expensive. Commercial software development, which most of us are in, skips a lot of corners. Things are allowed to break. Windows had a blue screen of death for a reason you'll never see in an aircraft. But in order to implement that at the commercial level, people wouldn't do. So yeah, QA is vitally important, but again, it comes down to where do you want to involve them? How educated are QA people on the actual test involvements with that, the documentation that they should provide before a single line of code is even written, and then you sort of waterfall from there. And then iterate, much to which Ahmed said is, it's a long, painful process, but at the end of the day, if you don't want that pager to ring, do a lot of work up front.
And you'll be surprised what you can get away with. You would be really surprised. I mean, QA is, I think we changed sort of the definition of quality now to the effect that sometimes clients, if you, instead of giving them a 500 error, if you give them like a reasonable, meaningful message, it's slightly better. It makes a little bit of a difference. So resiliency, I would rather focus on resiliency. I like the Netflix line where they said an error-free system is a fool's errand. We're just going to make sure that our system deals with errors properly. And this is where our monitoring tools, this is where all our monitoring systems come into. My dream is for the system to find the error before the client, and when the client calls, I say, yeah, we know about that, we're working on it. They'll be happy, I think.
So, I don't know if you're aware of it, there's this thing called Sentry. We use it extensively. Everything from kernel issues, a web application, a database. Any failure I get, it's real-time reported, it's triaged, we have it folded, analyzed, and I even link it to the source code commit by the developer. I've already closed the loop.
It's called Sentry?
Sentry, it's called. So it's an S. It's open source, you can also have it hosted. We've added a lot to it.
And when you say we,
so
you mean?
Where I work.
Okay, cool.
So what you're talking about, taking an exception and dumping it into a log file, I have it analyzed, and there's a JIRA ticket waiting for the developer because it's detected regression.
Yeah.
So, it's out there, and we've combined it with some of these metrics. So I actually have it that a developer's code can throw a pointer in the field, and within 5 seconds, he has an email. Your code broke, here's the stack, here's the contents, click a button, you can fix it. So
that'll be very interesting.
You're missing piece here.
So what do you do when the developer says it works on my machine?
Too bad, it didn't work on the customer's machine.
No, but not
he has all the data he needs to fix it. He doesn't have to reproduce it.
So that's what I was heading, right? You normally don't have all the production data to reproduce.
We gather all of that because our big mandate is thou shalt not reproduce. If you have to reproduce, you've already failed.
Yeah.
Because you can't. You can't keep crashing an airplane and killing pilots and burning fuel, and you'll never find it, right? So yeah, we collect all the data. We snapshot the stack, we get everything. And a lot of the frameworks, when you use Sentry with web UIs, I can see the buttons the user clicked, the actions he took.
Is it a hosted solution?
It's hosted, it's open source. I've actually extended it hugely internally. We've actually embedded it in the Linux kernel. But yeah, it's just getsentry.com. It's transformative. We have built an autonomous vehicle platform from nothing, and this thing has just propelled us.
This is great.
Yeah,
thank you.
You can take huge risks, you can throw out extremely reckless code, learn all these answers in near real time and iterate extremely rapidly. It's like a 10x improvement.
So I spent a year trying to talk my CTO to focusing on 2 tools only, and now you add a new one to me. Thank you. I really needed that.
Yeah, this
is I'm getting monitoring fatigue, to be honest, because like I think we had a civil war in the company a year ago between Prometheus, Elasticsearch, Splunk, and New Relic and Datadog, and figuring out what to do. This is one of the biggest. Honestly, I don't have an answer for that question.
Well, it's actually getting the developers taking more because we're starting to take Sentry data and feed it to Elastic. and I'm analyzing the mistakes our developers make.
So is it integrated with Elastic as well?
It can be, it's just JSON. So now I can actually go, well, these developers need to learn better pointer math. These developers need to learn these skills. We have opportunities for unit tests here. I can target precise changes in skill sets, behaviors, surface area, unit tests. I can measure it and then prove it to the business. I gained these returns.
You can tie Curelet code to the world.
Well, I have to work on that. But yes, it's
exciting.
We wouldn't have gotten as far as we did if I didn't use something like Sentry.
That sounds very exciting.
Sentry, you need to look at Sentry. You are using the stacks and work with it. I don't get a commission, unfortunately, but it's fantastic.
You should. Given the passion you have, you should. That's great.
It's very cool.
Okay, so I think we're coming to 8. I don't want to take anybody's time. Yes.
One quick comment. I think, so when you mentioned early on the talk that you had to look at 16 different servers on WebLogic, WebSphere, to figure out what the error was. So I've been there.
Yeah, this was the dark days of
I've
computing.
been there, I've been in the trenches. Every single time, like when I'm debugging something, I'm trying to figure out what went wrong. It's almost like I have to piece together a story.
Yeah.
To convince myself this is what happened, this is what led to the, right? Or more importantly, convince other people that this story actually holds. That this is not just something that figured out my imagination. Are there tools out there that could actually semantically help me understand the stack trace over here, the stack trace over here? They're all connected because there is a narrative that's going into this, right?
Very, very little, and things are getting worse.
It absorbs all the
Right up there.
Yeah. It absorbs all the metadata, and I go, oh, this problem only exists in data center A with service pack 2. I know the root cause.
It's just, the storytelling has been getting harder because now we are living in a REST world where there's no server affinity and no sessions. So your story is one HTTP call.
Well, things have become more complex because things are more async now. A lot of the applications are distributed. And it's not just 16 nodes anymore.
So
100 nodes.
So this is where Elasticsearch shines, and this is where we found. I'm glad you brought that up because this is part of. I'm sorry, just disconnect that. This is part of why we get the software development lifecycle early, because that async part is exactly why we did it. We use MDC, which is the context. Something I always forget what it stands for in Log4j. So Log4j allows you to have context data attached to the Log4j message, and it shows up actually in Elasticsearch as a field. And we started adding MDC context data in there, like host name, because you will always get the host name as where your file beat is, for example. But if you want your host name to be the exact host name when the error happened, we put it in there, and we started putting session IDs in there. Not Java session IDs, our own app session IDs. So we can correlate easily